Torque, it is the rotational equivalent of linear force. It is also called as the moment of force, rotational force, or turning effect. Another definition of torque is the product of magnitude of the force and perpendicular distance of the line of action of force from the axis of rotation. The symbol for torque is tau is equal to F for sin theta. The unit of torque is Newton meter. The above expression can be represented as the vector product of force and position vector. Tau vector is equal to R vector cross F vector. Angular momentum, the angular momentum of a rigid body is defined as the product of moment of inertia and the angular velocity. It is analog to a linear momentum and is subjected to the fundamental constraints of conservation of angular momentum principle. If there is no external torque on the object, angular momentum is a vector quantity. It is derivable from the expression for the angular momentum of a particle. Its SI unit is Newton meter second or kg meter second. Let us consider a body of mass m moves in the circular orbit with a velocity v. Let r a radius vector and theta angular displacement. Then the linear momentum p is equal to mv. The angular momentum of a particle of mass m with respect to a chosen origin is given by L is equal to mv r sin theta. Then by the vector notation, L vector is equal to R vector cross P vector. The direction is given by the right-handed rule, which would give L the direction out of the diagram. So for an orbit, angular momentum is conserved and this leads to one of Kepler's laws. For circular orbit, L becomes L is equal to mv r, where P linear momentum is equal to mv, then L is equal to mvr. The relation between torque and angular momentum. Consider a particle of mass m rotating about an axis with a torque tau. Let P be the linear momentum and R be the radius vector of a particle. The angular momentum of a particle is given by L vector is equal to R vector cross P vector. A relation between angular momentum and torque. A rate of change of angular momentum is equal to torque. Then L is equal to sigma Ri cross Pi, where I can take the values from 1 to n. Differentiating the above equation with respect to time t, we get dl by dt is equal to differentiation of d sigma I d by dt of sigma Ri cross Pi, the limits I is equal to 1 to n. Then sigma dri by dt into Pi plus Ri into dpi by dt, so based on partial differentiation, where I can take the values from 1 to n. But dri by dt is equal to Vi and Pi is equal to mvi. Vi, velocity of the particle, mvi, that gives the linear momentum. Dri by dt into Pi is equal to Vi cross mvi is equal to m into Vi cross Vi. So that indicates the cross product of same vector must be equal to 0. Then according to Newton's second law of motion, the rate of change of linear momentum is directly proportional to the applied force and takes place in the direction of force. So based on that, dpi by dt is equal to fi. So therefore, dl by dt is equal to sigma Ri into fi where I can takes the value 1 to n. Where Ri cross Fi, that indicates the product of force and the perpendicular distance between the line of action of force and the axis of rotation, the product that gives the torque. If the torque acting on the system of a particle is tau, then tau is equal to dl by dt. That means the torque is equal to rate of change of angular momentum, or the rate of change of angular momentum is equal to torque. So thank you.